So just as a reminder as well, as you're getting ready for your Unit 2 test, if you missed any days or if there's something you want to see again, all of the lectures from this class are up on YouTube. So you can go back and watch. You just see the screen as I write on it. But what we're going to do today in 7.6 is we're going to solve rational equations, and then Friday we're going to apply this. And in math, that's a fancy way to say word problems. So we're going to put this into word problems. So I just want to look at the difference here between an equation and an expression. And this was one of the first things I asked you when you got into this class. What's the difference between an equation and an expression? Equations have equal signs. Expressions do not. So your drill was just on combining, adding or subtracting expressions. What we're going to do today is solve equations. They need some of the same information, but after that they have very different processes for how you get your answer, just based on the fact that one has an equal sign and one does not. So I have a little recall here. When you're combining expressions, through our addition subtraction, you always use a form of 1. The nice thing about equations is you do not need a form of 1. When you have that equal sign, you don't need a form of 1 because all we're doing is keeping balance. When we're adding subtraction, we can't change an individual fraction's value. The only thing we can multiply by is 1. However, when we have an equation, we're just worried about did I do the same thing everywhere. So that's a big difference between equations and expressions. So we're going to start the same way. We're going to start by finding our common denominator. Still going to need that piece of information. The other piece of information we need before we get going are what are called restrictions. And we'll talk about that in just a second. Then we're just going to multiply by the LCD. We don't need a form of 1 because we have that equal sign. And what we're going for here is just clearing out our fractions. So if you took 082, at least the self-paced, I'm not sure about the lecture. When you solve equations that had fractions in them, what they teach you here, if you took it, is just get rid of the fractions. And then you don't have to worry about fractions. So we're going to do the same thing with these equations. When I see an equation that has a fraction in it, I'm just going to get rid of the fraction. So if I look at A, x over 5 equals x over 6 plus 2. There's two things you want to come up with before you start solving. And that's another thing. Read the directions. Solve versus add, subtract. First thing I'm going to come up with is my LCD. So I have two fractions there, a denominator of 5, a denominator of 6. What's my common denominator for 5 and 6? 30. So 30 is the smallest number that both of those divide into. Common denominator for 5 and 6 is 30. The second thing we want to talk about are restrictions. And this actually comes all the way back from 7.1. And we also looked at this sum in 8.3. So when we're dealing with rational expressions or fractions, there's a trouble area. What's the trouble area on fractions? When do I have trouble with a fraction? What are you saying, Napoleon? So there's something about the variables, but think back. Let's actually go back. Let's see if I can find. This will be probably top of the. It was a while ago now. So first thing we looked at, rational expressions are undefined when the denominator equals 0. So then we had gone through a bunch of examples where we took our fractions and we set the denominators equal to 0. And we said, okay, this denominator, the x couldn't be 0, and this, the x couldn't be 5/4 or -2. So you got to be careful. We can't ever have a value for x that makes the denominator 0. We did that in 7.1. We also did it some in Chapter 8. So when we're solving equations, why that concerns us is if we get down to an answer and it makes my denominator 0, we have a problem. We can't have that answer. So if I'm looking at these two fractions, I have a denominator of 5 and a denominator of 6. Are either of those ever going to be 0? Is it possible for these denominators to be 0? No. What's missing? Why can't they be 0? No variable. So for this particular problem, there actually are no restrictions. There's no value for x that I'm going to substitute into any of my fractions that would make the denominator 0, because it's 5 and 6. There's no variables there. So that ties right back into that 7.1. Denominators can't be 0. So now what we want to do is clear out all those fractions. So to clear out the fractions, I'm going to take each fraction in the original problem and multiply it by my LCD. So in blue here, this is just my common denominator. So I'm going to multiply every term, even if it's not a fraction, every term by my LCD. Now, if you'd like, you could also put that 30 over 1 if you like your fractions to line up. So you're welcome to always, I guess you don't really need it on the last one, but you're welcome to put the 30 over 1. It's the same. It's equal. Because what we should see happen here is we should see all the fractions go away. We should get rid of the fact that these are fractions. So let's look at this right here. X over 5 times 30 over 1. Think back to basic math. When I'm multiplying fractions, is there anything I can simplify there? 5 and 30. So 5 into 5 once. 5 into 30 6 times. So now I have x times 6 over 1 times 1. Well, x times 6 is 6x. And if I put it over 1, I don't really need the over 1. It's not changing its value. So look, we got rid of the fraction there. It's just 6x now. It's going to be a lot nicer to work with. Don't forget to bring down your equal sign. That's one of the big problems I see with these problems where people get confused is they don't bring down their equal sign and they're just left with a mess. All right, let's look at the next term. X over 6 times 30 over 1. What could I simplify there? The 6 and 30. So 6 goes into 6 one time. 6 into 30 5 times. So I'm left with x times 5 over 1, or just 5x. And then last, I have 2 times 30, 60. So this is now the equation that we're solving. It's the same equation. It's the exact same equation. It just doesn't have fractions. It's a lot nicer. So what type of equation is this? We've only had 2 types. What type of equation is this? You remember what it's called? We've had 2 types. The 2 types we've had are linear and quadratic. Linear. Linear. Why is it linear? There's no x squared in it. So you will see both linear and quadratic. That's why we would start recognizing which is which. So it's linear. It doesn't have x squared. It's just got x to the first power. So to solve it for x, you could have done this before you came into this class. I'm just going to subtract the 5x. So I have 1x, or just x, equals 60. So I've solved for x, but the last thing you want to do is check your restrictions. These answers aren't guaranteed to work. But for this particular problem, our restrictions were none. So whatever solution we get fits our problem. So we'll say x equals 60. And that's going to be the basic idea between all of these solve problems. When you're asked to solve, clear out your fractions, and then solve whatever's left over afterwards. So for B, I now have 4 fractions. I want these 4 fractions. I don't want fractions. It's so much easier if they're not fractions. So let's get rid of the fractions. So it says solve, you're trying to get rid of the fractions. So we need to start by coming up with our LCD. So I have 4 different denominators. I'm looking for a common denominator for 2x, 9, 18, and 3x. 18 will take care of the 2, 9, 18, and 3. So when you have numerical denominators, the place to always start is with the largest number. And if everything divides into that largest number, you're good. If it doesn't, start looking at multiples of the largest. So you'd look at 18, you'd look at 36, you do 18 times 3, 18 times 4, until you find one that they all divide into. So you always focus on the largest denominator, which in this case, the 18 actually works because I can divide 2 into 18, I can divide 9 into 18, I can divide 3 into 18. But that's not going to clear these. That's going to clear the 2, the 9, the 18, and the 3, but that's not going to clear my denominators completely. What else do I need in my LCD? X. You have to have the X because you see an X in any of your denominators. But at most, we've just got that one. The next thing we want before we get going, do you think I'm going to have any restrictions in this problem? Do you think there's going to be any restrictions in this problem?
Yes.
Why, Rob? Because there's x's in the denominator. So when you have it back to 7.1, if there's variables in the denominator, it's going to give us some restrictions. So 2 times what number would make this denominator 0? 0. 3 times what number would make this 0? 0. 0 is my restriction. So pretend now we're back in 7.1. You want to know for what value is this undefined? Well, what we did in 7.1 is we just set the denominator equal to 0 and solved it. Now a lot of these you can look at, but this is the work behind it. So we'd say, okay, x here can't be 0. Does this second fraction give us any restrictions? No, no variable in the denominator. Third fraction, any restrictions? No variable in the denominator. And then the last one, when we set the denominator equal to 0, it actually gives us the same restriction as the other one. So there's one restriction here, and that's x can't equal 0. So we want to be careful when we get down to the bottom that we check and make sure our answer's not 0. If it is, then we'd have no solution. So sometimes you can go through a lot of work on one of these problems, and there's no solution. So now I want to solve it. So I'm going to get rid of the fractions. Now the common mistake in getting this confused with what we did on Friday is that you look for different forms of 1 for every fraction to get it to the common denominator. But solving's easier than that. You don't have to consider each fraction separately for solving. When you're solving, you just take each fraction and multiply it by your LCD. It's less thinking in that sense. Is you don't need to look at each one individually. Each fraction just gets multiplied by the LCD. So it's just the LCD. Versus what do we multiply by when we're adding and subtracting? I didn't hear. If someone just said something, I did not hear what it was. What do we multiply by? It's 3 letters still. I abbreviate it with 3 letters. Form of 1. So make sure you keep that distinction for when you get to your test. When you're solving, this is the LCD. When you're adding and subtracting, that's a form of 1. That's the difference in these problems. So I'm going to multiply everything by the LCD. Now what should happen is I should get rid of all the fractions. Dennis. Yes. So what happens, let's pretend, I'm going to just look at this last one. Let's pretend I don't have the x on the 18. What's going to simplify in this problem right here? Yeah, so if I'm looking just at this last one, let's say I don't have the x on it. I have 1 over 3x times 18. What can I cancel out? Okay, so 3 into 3 once, 3 into 18 6 times. So then I'm left with 1 times 6, which is 6, and the bottom is x times 1. It's still a fraction. So the reason we have to include the x in that 18 is if I don't have it in my LCD, I'm going to be left with these x's in the bottom still. And what we're trying to do is we're trying to get rid of denominators altogether so we don't have to worry about fractions. So we need the, let me put this back here. We need the x on there to cover this x and this x. so that they'll cancel out too. So now when we go through, and this is where you'll tell if you have the right LCD or not, or a common denominator. Maybe it's not the lowest common, but common will work. Is when I go through and multiply these out, I should get denominators to cancel completely. If they don't cancel completely, that's when I know there's a problem. So we've got 4 different things to simplify. And again, if you want, you could certainly put that 18x over 1. So in this first fraction here, what's canceling? 2 and 18, so 2 and a 2 once, 2 and 18 9 times, and what else? The x's. That's why I have to include the x in my LCD, so those cancel. So I have 5 times 9, 45, and then my denominator is 1, so I don't need to include it. Next, again, you can put this 18x over 1 if you want. So what can I cancel in this second fraction set? 9 and 18. So 9 into 9 once, 9 into 18 2 times. Make sure you multiply everything out that's left in the numerator. So I have that minus 8 times 2x, negative 16x. Bring down your equal sign. And now I have 1 over 18 times 18x. Again, we can put that over 1 if we want. What's going to cancel? 18. So 18 into 18 once. 18 into 18 once. So I have 1 times 1 times x is 1x. You could also just write x. 1x and x are the same. But found people like the 1 there. And now this is still 3x. I didn't change this. But I have 1 over 3x times 18x. What can I cancel? 3x and 18x. So 3 into 3 once, 3 into 18 6 times. And then the reason we needed that x, so I can cancel that denominator out. So I have negative 1 times 6, negative 6. So this is our equation. All of that work up to this point was really just set up so that I don't have to worry about fractions. It's really just so I don't have to worry about fractions. This is what I'm actually solving. What type of equation? Quadratic, quadratic, linear, linear. What does it have to be quadratic? I know why you're saying, I think I know. You're saying quadratic because you see there's 2 x's. But that has to be 2 x's in the same term to give me an x squared. So this one's still linear. And when an equation's linear, it just has x to the first power. There could be lots of terms with x's, but none of them are x squared or higher. I want my x's to one side, my variables to the other. It doesn't matter which way you go. I'll take my x's left just because that's, and I find people tend to prefer that. So I'm going to take my 1x over. So I have 45 minus 17x equals negative 6. Then I'm going to take the 45 over to the other side. So I'm going to subtract 45. So I have negative 17x equals negative 51. Last step to solve for x, I'm going to divide both sides by negative 17. And it doesn't look like 51 should evenly divide by 17, but it does. X equals 3. But you can't always just finish running these problems and say, I'm good, I got x equals 3. Last thing you have to do is check your restrictions. Is it okay to have x equal to 3 in this problem? Yes. What's the only answer I wouldn't accept? 0. So we're good. Questions? Dennis. So we looked at every denominator that had an x. And we said, when does that equal 0? So I just want to know what value of x would make this 2x 0. So 2 times what number gives me 0? 0. That's the only possibility. So that means x couldn't be 0. Now here's my other denominator, 3x, the one that has an x. Again, we don't care about these two. They don't have x's. So 3 times what number gives me 0? 0. So they actually have the same restriction. So it's just what number would make any of my denominators that have an x with them 0. So x couldn't be 0.
So is it always x? It's not always x. 0.
No. So whenever you have monomials that have a variable with them, their restriction is always 0. But if you have monomials that don't have variables, none of them have variables, then there are no restrictions. And then what we're going to see coming up is we'll start having binomials. And they'll have restrictions other than 0. But when you have the monomials that have an x, their restriction actually is always 0. Any other questions? All right, C. Now your directions here are solve. So when you're solving, you don't use a form of 1. When you're solving, we're not going to use a form of 1, but we are going to need to start by finding our LCD. So what's my LCD for C? Y plus 2. It's the only denominator. It's the only denominator that is your LCD. I don't have to consider the 3 because the 3 is not a denominator. 3 is a numerator. So my LCD is y plus 2. So here's one that's a little bit different, Dennis. Restrictions. If I look at my denominator, and it's only 1, so I really only have to look at it once. What value for y would make y plus 2 equal 0? What number would I substitute in for y that would make this right here a 0? Negative 2. So negative 2 plus 2 is 0. So that's the only number I don't want. And if you want to solve for it, there is work you can do. You don't have to just guess. You just take your denominator with your variable, set it equal to 0, and solve it. And when I solve that, subtract 2 from both sides, there's my restriction. So if you look back, and it's been a while now since we keep getting pushed and pushed and pushed, this idea right here is actually in section 7.1. That idea right there is actually in 7.1. But my value for y that's my restriction here is a negative 2, because if I have negative 2 and I try to substitute it in, my fractions are going to be undefined. Yeah. It could be 0 here. Because what happens if I put 0 in for y? What's the denominator? It'd be 2. It's not 0. Right. You can't have it equal 0, and then when you solve it, that's the restriction. The only reason we got 0 in the previous problem was because it was a monomial. You get 0 from monomials. From binomials, you're going to get something other than 0. Any other questions? These are all great things to ask. All right, next we want to clear those fractions out. What am I going to multiply by to clear out the fractions? Y plus 2. I'm going to multiply by my LCD. I'm going to use some parentheses. So that's the difference. That's the difference between solving and adding. When we add and subtract, we use a form of 1. When we solve, we multiply everything by the LCD. Bless you. So I'm just going to set it up so everything gets multiplied by the LCD. And now I've got 3 things, and what should happen if my LCD is correct is I should end up canceling out all the denominators. So in this first fraction here, what can I cancel? Y plus 2's. That looks like more of what we did in 7.2. I can cancel them out because they're the same factor. So I'm left with 10 times 1 or 10. What do you think is going to happen in this next term? 3 times y plus 2. Or what am I going to have to do? Because there's no fractions. Yeah, I see a lot of fingers going through the air. Yeah, we're going to distribute. We're going to distribute the 3. That's another reason it's important to put those binomials into parentheses. Here we're going to distribute the 3. So I have 3y plus 6. And what's going to happen over here? And cancel those y plus 2's again. So I'm left with minus 5y. So what type of equation is this? This is what we're solving now. No fractions. Linear. Doesn't have an y squared. Just got y to the first power. What's the first steps to solve this one? Combine like terms. The y's are on the same side. If the y's are on the same side, they go together. So it's going to be negative 2y plus 6 equals 10. My y's are all on the right side, so I'm just going to move my numbers over to the left. Subtract a 6. So I have 4 equals negative 2y. And divide by negative 2. And I get y equals negative 2. Should we box that in? No, why not? It was our restriction. We said at the beginning, y can't be negative 2. Y can't be negative 2 because if I substitute that back in, if I go to try to check this, all I'm going to get is undefined and undefined. So, unfortunately, when I check my restrictions, this doesn't work. So the answer I'm going to box, the answer I'm going to write on my answer line, no solution. It doesn't check. My restriction is that y can't equal negative 2. So I can't turn around then and say y equals negative 2. If you tried to check your answer of negative 2, as soon as you substitute into your first fraction, it's undefined. Doesn't work. So the whole problem, all that work, no solution. Ayana. Right.
But if it's the number and the variable, then you have to do that to make sure it doesn't equal 0.
Yes.
And if it's like that, I have to make sure that negative 2 is probably 2 don't equal 0.
You have to make sure.
Oh, not negative 2. My restriction would be negative 2.
Yeah, you have to make sure. Yes. So. Yes. So question about the restrictions, which usually are the most questions on these prompts. So if you have just a number in the denominator, we're just summarizing a little bit here. So just a number in the denominator, it does not give you any restrictions. If you have a monomial that has an x with it, restriction of 0. If you have a binomial, set it equal to 0 and solve. That will give you your restriction. When you get down to your final answer, take it up against your restriction list. Make sure it's not there. If it is, you can't have it. If that was your only answer, no solution. Dennis. Okay. So if it's a solution, that means I should be able to substitute it in here and get a true statement. So let me go back to this one. So in this first problem, we said that our answer was 60. So what we should be able to do in that case is check. We're going to take 60 over 5. So I'm just going to go into my original problem and replace all the x's with 60. And I want to know, is that the same as 60 over 6 plus 2? So if our answer is a solution, this should work out. So 60 divided by 5 is what? Close. 12. So what should happen is I should get 12 on the other side. So 60 divided by 6 is 10 plus 2. Okay, so it works because I got the same thing on both sides. That's how we know a solution's true. Yeah, but what happens if we try our negative 2 here? Let me put this over here. So if I start my check, I should say 10 over 2 minus 2. I want to know, does that equal 3 minus 5 times, oops, sorry, this was negative 2 plus 2. That's what it looks over negative 2 plus 2. Well, as soon as I start this left side here, I have 10. What's negative 2 plus 2? So I have 10 over 0, which is undefined. I can't check any further. That fraction doesn't have a value. So it's not possible for it to equal the other side because it doesn't have a value itself. So this is what we're trying to avoid here. And that's why we have to make that list in the beginning to make sure we don't get any of those numbers at the end. So since that's undefined, we can't check it. It doesn't check. Any other questions? We're going to have to need to know this whole process for Friday's problems. Fridays is then we have to set these up from words and then solve them the same way. Rob?
Wouldn't the other side just be 0 too?
It's not 0 though, it's undefined. So 0, the other side's going to end up being, what do we have? 3, oh my line went too far. Let me make sure this is clear. Our other side is going to end up being 3 plus an undefined fraction. So if they're undefined, then there's no solution. Even if you get both sides to be undefined, it still doesn't work. They don't equal each other in that sense. Any other questions? All right, let's look at this last guy then. So I have 3 fractions again. First thing I need when I'm solving is the same thing I need when I'm adding or subtracting. I need an LCD. So what's going to go into my LCD here? So remember, when we're working with binomials, these are package deal here. How many different denominators do I have? 2. There's 2 different denominators. There's a single x, and then there's x minus 3, which that one repeats, so it's not different. So I need to account for the 2 different denominators here. I need to contribute from each of the 2 different denominators. So the first thing I need is the x, all by itself. A monomial x is not the same as an x that's part of a binomial. The other factor I need is that x minus 3. Anna. It's one of them. So 2 different denominators. Both denominators have x's. That means that there are 2 different restrictions. I need a restriction for each different denominator that has an x with it. So my first denominator is an x that's a monomial. What's the restriction for a denominator that's a monomial with an x in it? 0. What value for x would make x 0? 0. So my first restriction is that x can't be 0, because if I take my first denominator and set it equal to 0, well, that's the restriction. There's nothing left to solve there. Monomial, it's got an x, its restriction is always 0. There's a different restriction for x minus 3. So think about what minus 3 gives me 0? 3. The other way you can get that answer is you take your denominator, you set it equal to 0. And when you solve that, you get your restriction, positive 3. So there's 2 numbers we can't have for answers. We couldn't have 0, we couldn't have 3. Is everyone okay with those 2 restrictions? All right, so let's go through and get rid of these fractions. This problem's going to be a lot easier without fractions. So I'm going to take each term and I'm going to multiply it by the LCD. That's a difference. This is something that's different than adding and subtracting, where we use a form of 1. Here we use our LCD. I'm going to put all of those binomials into parentheses. So all binomials should go into parentheses. Now we're going to multiply everything by the LCD. and let's see what cancels and what's left over. Alright, so I have 1 over x times x minus 3. What can I cancel? Those x's. Those can be gone. So I have 1 times x minus 3, which technically we're distributing the 1, but it's not very exciting. X minus 3. What's going to cancel my next term? X minus 3 again. So I have 1 times x is 1x, or just x. Don't forget to drop your equal sign down wherever it occurred in the problem. We're still solving. And then what's going to cancel on this side right here? X minus 3's. So I'm left with x minus 2 times x. What am I going to need to do here? Distribute. So we actually had an example like this. I think it was the first day of class we even did it, where the monomial was at the back. You've still got to distribute it into the parentheses. So we're just going to take the x back this way. If you want to start by writing it as x times x minus 2 and distribute it kind of the front way, it's okay. You've got to do it either way. So I have x squared minus 2x. So here's my equation. Here's my equation sans denominators. What type of equation is this? There's my quadratic. We knew it would come back. I would actually start, before I go into my quadratic solving steps, by simplifying that left side. Since I have this x plus x, I could say it's 2x minus 3 equals x squared minus 2x. What are the 2 steps to get me going on solving a quadratic? First thing that has to happen, back from 6.6, it's got to be equal to 0. So now we're going back to 6.6, solving quadratics. Which side do I want to bring everything to? Do I want to bring everything over to the left or everything over to the right? Over to the right. I like that x squared being positive 1. It's going to be my best case scenario. So to move 2x, I'm going to do minus 2x. I'm just going to line it up with its like term. To move that negative 3 over, I'm going to add 3. Just going to tag it on the end since there's no other like terms. So I have 0 equals x squared minus 4x plus 3. And if you want to put the equal 0 on the right, it's okay. It's the same. So if you want to write x squared minus 4x plus 3 equals 0, it's the same thing. So when I have a quadratic, this again is 6.6. After I set it equal to 0, what do? Factor. So I'm looking for a pair of numbers that multiplies to positive 3, adds to negative 4, which is going to be negative 3 and negative 1. So there's my factors. It's still equal to 0. And how do I get my answers? Separate them. Set them each equal to 0. Just when you think things are going away, pop it right back up. So this is solving a quadratic. This comes from section 6.6. So I get 2 answers since it was a quadratic. I get x equals 3 and x equals 1. Am I ready to box? No. What's wrong with that answer? One of my restrictions is in my solution. So the last thing to do is to check your restrictions. So if I go back up to my restrictions, I had 2 numbers that I said x couldn't be. X can't be 0 and x can't be 3. So if I look at the 2 answers I get to the quadratic, one of those restrictions is here. I said x can't be 3. Do I have any problems with x being 1? No. So that means there's a solution here. You wouldn't write no solution, but your answer is just x equals 1. So our quadratic gave us 2 answers. Quadratics can give us up to 2 answers. But when we went back and checked our restrictions, only one of those worked. So it's not no solution, but we got to throw away that 3.